So hey everyone, welcome back to Code with Carrie. Today we are going to solve a question based on binary trees. Till now we have learned about binary trees, their implementation, and we learned about traversal, different types of traversal techniques. Those were level order traversal, in order, pre-order, and post-order traversals. So if you still haven't checked out those videos, you should surely go back and check the playlist. So for now, we are solving this question, which is to calculate the maximum height of a binary tree. So the problem statement goes like, given the root of a binary tree, return its maximum depth. So what is basically height? So height is the longest path between the root node and leaf node. So suppose what's the root node here? We have 3. And what's the leaf node? We have 9, 15, and 7. If we take the case of this diagram right here. So what's the so if I try to calculate the height, so what will be the height? So if I go take the path from 3 to 9, so here this can be one height, from 3 to 15 this can be one path, and 3 to 7 that can be one path. So we have 3 total paths here from root to leaf node. Now the height here will be 2 because that's the number of nodes coming in between them. So we have 9 and 3, 2 nodes here. While going from 3 to 15 we have 3 nodes, 3, 20, and 15. While going from 3 to 7 we have again 3 nodes, which are 3, 20, and 7. So what was the maximum height of this tree right here? It will be 3. So yeah, I hope you got it. So now suppose this is the question we have. So what we're doing is we will be making use of recursion to solve this problem. So what will I do is I basically what will recursion do? So what will it do is it will go to the left subtree, give me the height of the left subtree, then it will go to the right subtree, it will go bring me the height of right subtree. Then what will I do is I'll just sum I'll take the maximum of left or right and just add 1 to the final. Since I've already solved this problem, I'll just explain it to you. So this was the graph we were given. So what we were doing is we were sending recursion first to the left side. It was giving the height of here, and then we were sending recursion to the right side. It was giving height of this right subtree right here. So this is our code right here. So this is the main function they gave us. So first condition we wrote here was if root goes null, then we have to return 0. Means if there's nothing in the root node only, then we will just return 0, right? Then what we are doing is we are sending recursion for the left side. So I just made a variable left. So left was storing the height of my left subtree. Then I made right variable which stores the height of the right subtree. So this is how recursion goes. And in the end, what we do is we calculate the maximum of left or right, and we just add 1 for the level. So yeah, that is how the code works. Now to give you a better visual perspective, let's move on. So yeah, this is how we are working over here. Suppose this is the tree we were given, right? So what we are doing is first we are here. We are checking if root is equals to null. No, it is not. Then we will go left. While going left, we come from 3 to 9. We are here at 9 now. So 9, it says again go to left. Once we come at 9, it says again go to left. But is there something on the left of 9? No, we don't have anything. Then it says go to the right of 9. Do we have anything on the right of 9? No, we don't have anything. So we'll just come back here. So this also will return 0 value. This also will return 0 value. And then once we reach here, so what will the ans here? We create the variable ans, right? So what will be ans here? It will be 0, maximum of 0, 0 plus 1. So what will be the value we have here? It will be 1. So what will 9 return to 3? 9 will return 1. Now we will go to the right of 3. So once we arrive here, we arrive at 20. Once we arrive at 20, it says go to the left of 20. So we arrive at 15. Once we arrive at 15, it again says go to the left of 15. Is there anything here? No. Now it says go to the right of 15. Is there anything here? No. So we will return 0 here again. So once we return 0 from here, so maximum of left and right is 0 again, and we'll just add 1. So the value returning here will be again 1. So means from 15 we will be returning 1 to 20. Then once we arrive at 20, we'll be going to right of 20, which will be 7. So from 7 again it's 0, 0 on the left and right side. So we'll again come back. It will return 1 because maximum of 0, 0 plus 1, it's 1. So once we arrive at 20, as you can see now we have 1 and 1. So maximum of 1 and 1 is 1 plus 1, which will be 2. So 20 will be returning 2 towards 3. So now we have 2 here. So the left subtree returns 1 and the right subtree returns 2. So what is the maximum of left and 1 and 2? It's 2. So our final answer will be 2 plus 1, which will be 3. So yeah,